Okay, good afternoon. Welcome to
FamilyMath number 125.
FamilyMath125, coin flipping. So today there was a guy who's in graduate school in math at somewhere in Illinois, and he wrote a blog post that some people were writing about, and I checked out his blog, and he had a really cool article about coin flipping, and it's about how, if you have a coin that doesn't flip heads 50-50, heads and tails, how you can make still a fair coin out of it. Okay, so do you have a coin?
Yeah.
Can you flip it? Okay, so that came up heads. Okay, do we have another coin? Okay, flip it. Good job. Oh, hey, that also came up heads. Awesome. Okay, so what we're going to do, we're going to use the example that he used on his blog, and we're going to pretend our coin flips heads 20% of the time.
Yep.
And tails 80% of the time. In fact, we're going to pretend both of these coins do that.
Yep.
Okay, and we're going to try to make something that flips, or where we can still make 50-50 decisions. We're going to try to make something that's random using our broken coins. And it's 50-50. It's not just random. Like, this is random, right? 20%, 80%?
Yeah.
But we want it to be 50-50. So that's going to be really cool. And so why don't we go to our whiteboard first, and then we're going to go actually make a computer program on Khan Academy to test out, to see whether it works or not, okay?
All right. Yeah.
All right, here we go. Okay, so here we are at our whiteboard with our coin flips. And so we're going to look at when we flip coin 1, how often did I say we got heads?
You said 20%.
20%. And how often tails?
80.
80, okay. And coin 2 is the same, right?
Yeah.
So if I flip one and I flip the other one, we should be able to figure out how often I get 2 heads, a tail and a head and a tail and 2 tails.
Yeah.
Right? Okay, so coin 1 flips heads 20% of the time, coin 2 flips heads 20% of the time. So since those are independent from each other, we can just multiply 20% times 20% to see how often that happens.
Yep.
Now, we haven't really talked about percents, but you have. Do you know what 20% times 20% is?
It's 40 over 200. Wait. 20 over 100.
Yeah.
Times 20 over 100.
Right.
400 over 10,000.
Right. So 400 over 10,000. That's certainly one way to look at it. Is there a better fraction that we could use for 20% rather than 20 over 100?
Well, we can use 1/5.
We could use 1/5, and even making the multiplying easier, actually 2 over 10 makes the multiplying a little easier.
Yeah.
Do you see why 1/5 is 2 over 10, by the way?
Yeah, because you multiply each side by 2.
Yeah, good job. High five. Okay. So what is 2 over 10 times 2 over 10?
It's 4 over 100.
So what percent is 4 over 100?
It's 4%.
4%. So 4% of the time we should get 2 heads.
You can see that just by taking off 2 zeros here.
Yeah, exactly right. Now what about a tail and a head? That would be 80% times 20%.
But it's 4/5 times 1/5.
80% times 20%. Yeah, and right, it is 4/5 times 1/5.
Or 8/10 times 2/10.
Yeah, 8/10 times 2/10 is actually a really helpful way to think about it.
So we get 16/100.
Okay, and what is that as a percent?
16%.
16%. Okay.
It's
Now for heads and tails. We get heads is 20%.
Yeah.
Tails is 80%.
Yeah, shouldn't we get the same thing?
Same thing
We do get
because
the
it's
same thing.
commutative.
16%. And then finally, tails and tails should be 8 over 10 times 8 over 10.
That's going to be 64%.
8 over 10 times 8 over 10. Which is, what is 8 over 10 times 8 over 10? Do you know?
It's 64 over 100.
Very good. Which is 64%. Now, this hopefully is going to add up, by the way, to what? What should these percents add up to? 100%. Right?
Yeah.
Why is that?
Because because all percents have to add up to 100%.
Well, those are all the choices, and then all of it should add up to 100%. And the interesting thing here, and the great observation that's pointed out in this guy Jeremy's blog, is that these two probabilities are the same.
Yeah.
So every time I end up in one of these buckets, I should end up in those about the same amount of times, right?
Yeah.
And so all we're going to do is when we end up in one of these buckets with heads and tails, with the coins being different.
Yep.
Whatever they are, we're going to take coin 1. Okay? So if I get a tail and a head, we're going to, our secret flip is going to be a tail. When I get a head and a tail, our secret flip is going to be a head. When I get 2 heads or 2 tails, I'm just going to ignore it, okay?
Yeah.
And so you can see about 32% of the time, 32% of the time, 16%, 16%, we should actually get a good flip.
Yeah.
Okay? So now, we could go do this with coins a bunch of times.
That would take a long time.
That would take a long time, but instead we're going to do it with a fun little computer program on Khan Academy, okay?
Yeah.
All right, you guys see kind of generally what the idea is here?
Yeah.
It's actually pretty neat. I'm actually very excited to see how this works. All right, let's go write our program. And then we'll talk about it on video. We won't write it on video. We'll talk about it, okay?
Yeah.
Okay, so here's our computer program. We'll just run through it quickly. We're going to do 1,000 trials.
Yep.
I'm just setting up some variables, heads, tails, and success. Okay, so you can see this when we ran this, we got 159 heads, 184 tails, and 343 successes.
Yep.
Okay. Probability is 2. I'm going to pick a random number from 0 to 10, so 20% is 2 out of 10.
Yeah.
Okay. Flip 1 and flip 2 are just variables I'm making. I is just a variable to count. We do our for loop. So our flip is a random number from 0 to 10, flip 1 and flip 2.
Yeah.
If flip 1 is less than or equal to my probability, it's less than or equal to 20 or 2 out of 10, then I get a head, which I'm calling 0. Otherwise it's a tail, which I'm calling 1.
Yeah.
Okay, same for flip 2. So this is, I didn't do this as best I could, but I wanted to make it easy to read.
Yeah.
So if the flip 2 is less than the probability, it's a head, otherwise it's a tail. And then we just compare. If flip 1 is not equal to flip 2, that's what we wanted, right?
Yeah.
Then we just look at flip 1. If it's equal to 0, we get heads, otherwise it's a tail.
Yep.
And then we just add them up, okay? And then down here we print. But let's run this a couple of times. So we're going to do 1,000 trials, and remember we expected success about 32% of the time.
Yeah.
So let's see. Oh, that's close. We got 309 out of 1,000, which is real close to 31%, right?
Yeah.
Yeah.
So.
And we got heads and tails kind of close, right? Remember, we expect it to be about half each, about 160 each every time. Okay. Close. Getting kind of farther away. Have we ever had
Yeah.
tails more than heads yet?
I don't think so.
Well, that's close.
Oh, wait, tails more than heads.
Cool.
This is pretty interesting. So you want to try 10,000 trials?
Sure. Wow.
Oh, now we're getting really close. We should be getting 1,600 and
I'm
about
not sure if it goes bigger than 10,000.
32% of the time. Pretty close. Pretty close.
Very close.
This is pretty neat, right? So this is simulating a broken coin that only flips heads 20% of the time, but we're still able to get something that tells us that something that's 50-50. So we can make a working coin for purposes of coin flips out of a broken coin.
Awesome.
That's pretty cool math, I think, don't you?
Yeah.
You like that?
Yeah.
Maybe we should try this. Try some other ways of doing this. You want to try? Well, tell you what, after we turn off the camera, we'll try changing this probability. All right?
Sure.
All right. All right. Good job, guys. That was fun.